Hello and welcome to this lesson for Chemistry 20. This is the final lesson of the Science 10 Chemistry Review units that I complete with my Chem 20 students prior to starting the bonding unit. So this last lesson is going to review our calculations of mole and mass and converting between mole and mass and molar mass. Now, because we're going to be completing calculations, it's important to review significant digits, scientific notation, rounding, and unit analysis whenever we're doing calculation questions. So let's say you're taking 100 and dividing by 15 and you get an answer of 6.6666, so on, repeating. We never record our answer as 6.66 repeating. We never use the repeating symbol in science. Instead, we have to round it to the proper number of what we call significant digits. There we go, significant digits. Okay, so the proper answer for this question would be 6.7, and we'll look at how we do that. So it depends on the numbers you're given in the question and which mathematical operation you're performing. So first of all, let's review what a significant digit is. First of all, any digit from 1 to 9 is significant. It's the zeros that come into question, and it depends on where they are in the number. If they are a trailing zero, they are significant. So for example, 6.3800 has 5 sig digs. Every digit counts. Same with 12,000. Every digit counts. If the zero is what we call a sandwich zero, meaning it's in between the digits 1 to 9, they also count as significant. So 2.04 has 3 sig digs, 1005.002, every digit counts. There's 7 sig digs in that number. Last are leading zeros. These are the zeros that are not significant. So the number 0.0065, those leading zeros do not count. Only the 6 and the 5 count. And so that number only has 2 sig digs in it. Okay? So basically, every digit counts, zeros count unless they're a leading zero. So you have 0 point something. That leading zero and any zeros after it, up to the first digit 1 to 9, do not count. Okay? Now the reason sig digs matters because most of the time we're going to be multiplying and dividing, and when you're multiplying and dividing, you're going to round your answer to the lowest total number of sig digs as the number that are given in your question. So for example, let's say I'm taking 2.00, which has 3 sig digs, and I'm multiplying it by 20.00, which has 4 sig digs. The lowest sig digs is the 3, so my answer needs to also have 3. When I put this in my calculator, I get 40. I have to add a decimal 0 after it. Anytime your number needs to be bigger than what it is, you add a decimal 0, and you get an answer of 40.0 to 3 sig digs to match the 3 sig digs in the lowest number of sig digs in the calculation that you're doing. Okay, so most of the time you're multiplying and dividing, but sometimes there is adding and subtracting. When you're adding and subtracting, the rules are a little different. You're going to round your answer to the lowest number of decimal places only, looking at decimal places. So for example, I have 5.2 that has 1 decimal place. 2.35 has 2 decimal places, so the lowest is 1 decimal place, which means I have to round my final answer to 1 decimal place. When I do this calculation, I get 7.55. I'm going to cut it off right there to keep my 1 decimal place, and whatever I'm cutting off, if it's a 5 or more, it rounds the last digit that we're keeping up. If it's a 4 or less, it doesn't round up. Okay? So most of the time, we're multiplying and dividing, so you're looking at the lowest total number of sig digs. But if you are adding or subtracting, you just look at the decimal places. Okay? Now, scientific notation. Let's say you get a number that's longer than the digits you're allowed to keep. So let's say you get an answer of 5,655 and you're only allowed 2 sig digs. What you're going to have to do is the decimal is currently at the end of the number in the number 5,655. You're going to move the decimal to after the first digit. My arrow and my lines here are a little bit off, but I'm moving it over 1, 2, 3 places. I keep the 5.6. I'm cutting off a 5, so it rounds the 6 up to 7. So it becomes 5.7 times 10 to the power of 3. 3 is the number of decimal places we moved it over. We moved it over 1, 2, 3 places. So if you're moving your exponent over in the left direction, the exponent is positive. But let's say I had a number 0.00623 and I wanted to round that to 2 sig digs. Again, I could just put it as 0.0062 because the leading zeros don't count, but let's say it asks you to put it in scientific notation, or the answer is given in scientific notation. It would be 6.2 times 10 to the 1, 2, 3, negative 3, because I'm moving it in the right direction. Okay, so if you're moving it to the left, it's a positive exponent. If you're moving it to the right, it's a negative exponent. And again, the exponent is how many places you move the decimal. Okay, SI prefixes. Sometimes you will be given a number that has an SI prefix in front of it, such as a milliliter. The milli is an SI prefix. SI prefixes are given on your periodic table. It tells you what they're equivalent to. So a milli is equivalent to 10 to the minus 3. So if I want to take milliliters and convert it into liters, I multiply by what it is equivalent to, which is 10 to the negative 3. This is the same as dividing by 1,000, but maybe you're going to have a question where you have a megaliter and you don't know how to convert it. If you have a megaliter, a capital M, you're going to multiply by 10 to the power of 6. Okay, so when it has an SI prefix and you're trying to convert it into the standard units, you multiply by whatever. So to go from kiloliter to liter or whatever, you multiply by what the value is. But if you have a liter and you want to go back and put it into kiloliters, then you divide by what the exponent tells you. So for example, if I have a liter and I want kiloliters, I would divide by 10 to the 3. Okay, so to get it out of SI prefixes, you multiply it. To put it into an SI prefix, you divide it. The last thing we'll look at before we get into our mole calculations are looking at unit analysis. So when you look at your units, you can kind of figure out what units your answer should be in. Whenever you're adding, the two numbers you're adding have to have the same units. Okay, so they're both moles, so my answer will be in moles. Notice again how I'm adding here. So my decimal places are what's significant. There's no decimal places in either of them, so I need no decimal places in my answer. So 12 moles is my proper answer. Let's say though I'm taking 10 liters and I'm multiplying by 2.0 moles per liter. The moles per liter means the liters on the bottom of a fraction, and when I put them together, the liter on the top and bottom will cancel, and we'll get left with moles on the top. Whatever you're left with on the top is always what your final answer should be. So this answer to proper sig digs would be 20 mole. Okay? So as we're going through our calculation questions, we'll look more at this, but this is just kind of a review again of your unit analysis when completing a calculation question. So what we're going to talk about now is the mole and how to convert between mass and moles, because kind of the common language in chemistry is moles. A mole is essentially just a number. It just represents a large pile of atoms or molecules that it takes to really get a tangible, like handheld amount of that substance. Okay, so if I were to tell you you have a dozen, that means you have 12. If I were to tell you you have a mole, you have this number, 6.022 times 10 to the power of 23 atoms, molecules, ions, whatever you have a mole of. That's what the mole represents. Now in our formula, the mole is going to be represented with an N. Think of the N for number. It represents a number. Okay, now the formula we're going to use to convert between moles and mass is going to include something called molar mass. The molar mass in our formula is going to have a capital M. Okay? To find the molar mass, and the units of molar mass are grams per mole. That's telling us how many grams we have when we have 1 mole of our substance. So in order to find molar mass, what you need to do is look up the individual mass of each element and add them times the number of atoms there are for that element. So for example, I have 1 carbon. Carbon is 12.01. I'm going to add that to 2 oxygens, which are 16.00. I put it in my calculator exactly like this. And again, you don't have to put the 1. You can just put 12.01 because the 1 times that number doesn't really change anything. But I do need to put a 2 in front of my 16.00. And I get an answer of 44.01 grams per mole. Now, technically we're adding here. The 2 is just like a counted number. It doesn't count as multiplication. It's just saying how many of the oxygens we're adding. So I'm looking at my decimal places. I have 2, so my answer for my molar mass should always have 2 because all the digits on the periodic table have 2, the periodic table that we use. Okay? The next one, I have aluminum. There's 1 aluminum, which is 26.98. There is a 3 in brackets after the hydroxide. So everything in the brackets gets multiplied by that number. So there are 3 oxygens and 3 hydrogens. Okay, when you have a polyatomic ion, you break it up into the individual elements that make up that ion. So 26.98 plus 3, 16.00 plus 3, 1.01 gives us 78.01 grams per mole. And the last one, think of the name of this polyatomic ion, because sometimes students ask, is that carbon and iodine or is that chlorine? The name is chlorate, meaning chlorine. Okay, so I have 1 copper. Copper is 63.55. I have, again, in brackets, a 2 after the brackets. So that means there is 2 chlorines, which are 35.45, and 6. 3 times 2 is 6 oxygens. Okay, so 63.55 plus 2, 35.45 plus 6, 16. We get an answer of 230.45 grams per mole. Again, my sig digs are my decimal places. Everything had 2 decimal places in the masses that we were taking, the individual molar masses. So my final answer needs 2 decimal places. Okay? So that's a review for calculating molar mass. Now again, what is our formula for moles? And this is the formula that, again, formulas are not given on your periodic table. You have to memorize them. So N is the moles measured in MOL. The little m is the mass, which needs to be in grams. And the big M, like we just looked at, is the molar mass in grams per mole. So let's say we have this formula and we want to rearrange to solve for something else. Let's say we want to rearrange to solve for mass. Okay? Right now, in order to solve for mass, I need to get rid of the molar mass. The molar mass, I need to isolate for the variable I want to find, so I have to get rid of everything else. The molar mass right now is at the bottom of the denominator position of this division symbol. So I have to do the opposite to get rid of it. So if it's being divided, the opposite is to multiply. And what I do on one side of the equal sign, I have to do on the other side. Okay, so now my molar mass here can cancel, and I'm left with mass equals moles times molar mass. Okay, so if we're rearranging to solve for mass, it's moles times molar mass. Now let's say I want to solve for molar mass, because sometimes that could be a question. In order to solve for molar mass, again, I want to isolate for my molar mass. I have to get rid of the n. Right now it's multiplied by n, so the opposite would be to divide by n, and again I do the same thing on both sides of the equal sign. So my n cancels, and I'm left with molar mass equals mass divided by moles. Okay? Mass is moles times molar mass, and moles is mass divided by molar mass. So kind of the three different variations of this formula rearranged for depending on what you're looking for. If you're looking for, again, moles, because you're given mass. If you're looking for molar mass, because you have mass and moles and maybe an unknown substance you're looking for the molar mass of. Or if you're looking for the mass in grams, because you're given the moles. Okay, let's look at some examples of using this formula. How many moles? So we are looking for N. We're told we have 8.06 grams. That's my mass. 8.06 grams. I need to know my molar mass. Now, I'm given the name of my compound. Whenever you're given the name of the compound, you need to first write the formula for that compound to know how many magnesium and how many oxygen ions are in this compound. So if I balance ion charges because it's ionic, again, a metal with a non-metal, I have 1 magnesium with 1 oxygen. Okay, because there's a 2 plus and a 2 negative. But don't forget to always, first of all, write the formula for the compound. The molar mass of that would be 40.31 grams per mole. Okay, so I can write that down here. Now I'm going to put it into my formula. So my formula for moles was mass over molar mass. Okay, so my mass is 8.06 grams and my molar mass is 40.31 grams over mole. Now there's a rule in math. When you have a denominator in the denominator of a fraction, it actually moves up and becomes part of the numerator. So the mole is really up there. Now, do you have to move it? No, but you'll see me commonly do that just for unit analysis so I can show how my grams cancel and I'm left with moles on top. Whatever I'm looking for should always be left on top. So that's why I moved it up there, okay? 8.06 divided by 40.31 gives us an answer of 0.1999 so on moles. Now sig digs. So I'm multiplying and dividing. So I look at the total digits sig digs in each number. There's 3 sig digs and 4 sig digs. The lowest is 3. Leading zeros don't count, so my 3 would be cut off 1, 2, 3 after the second 9. Now, I'm cutting off something greater than a 5, so it's going to round this 9 up. Now, only in this case, because it's a 9, is it going to bump up this one and then that one, because they're 9s, so they keep bumping up. Otherwise, you only bump up the last one you're keeping, but because these ones were 9s, they round all the way up. Okay, so my final answer to 3 sig digs, and I always put a box around my final answer or underline it, whatever you want, just so it's easier for your teacher to see what your answer is. I get 0.200 mole. Don't forget units on your answer. Again, leading zeros don't count, so it's 0.200 mole. If you were to put that in scientific notation, it'd be 2.00 times 10 to the negative 1 mole if you wanted scientific notation. Okay. Next example is looking at mass. What is the mass? I am looking for M this time. I am given my N, my moles. 0.677 is my mole, my N value. And I have potassium sulfide. So again, I need to figure out the formula of this compound before I can figure out the molar mass. There needs to be 2 potassiums with my sulfide in order to make this balance. Potassium is 39.10, there's 2 of them, and sulfur is 32.07. So we get a molar mass of 110.27 grams per mole. Now, my formula for mass, we already looked at rearranging it, was moles times molar mass. So my mole is 0.677 mole, and my molar mass is 110.27 grams over mole. I'm just, again, putting this line here, this division symbol, there's no number at the bottom. I'm not dividing by anything. It's just to show how I have a mole on top and a mole on the bottom so they cancel. And I'm left with an answer in grams. So 0.677 times 110.27 gives me an answer. I'm just multiplying. That division symbol again was just to look at my units. I get 74.65 so on grams. Again, I look back at the question. Leading zeros don't count. So there's 3 sig digs and 5 sig digs. The lowest is 3. So if I can only keep 3, I'm going to cut it off after my third digit, which is the 6. I'm cutting off a 5 again, so that's going to round that up, and I'm going to get an answer of 74.7 grams as my final 3 sig dig answer. I don't need to put it in scientific notation because I'm not cutting off the decimal. The decimal is part of the answer there. Okay? And that is it for mass, molar mass, and mole calculations. Thank you very much for watching this video.